10.6 is solving radical equations now. So this is going to be, I did, thank you. Something that is new, but also it's solving equations, and you guys know how to solve equations. So there's one step that's new is really what it comes down to. Other than that, you'll be great. So here's the deal. In order to solve radical equations, there are 4 different steps that you want to make sure you do. Okay, the first one is much like when you're solving for just a variable, you have to isolate it, right? The goal is to get the variable by itself. This is the same thing, but you want to isolate the radical. What does it mean to isolate? Get it by itself, get it alone. So you want to get the radical all by itself on one side of the equation. And then once you've done that, that's when the new move comes into play. And you square both sides. What does it mean to square something? Lincoln, put the watch away. What does it mean to square something? Take it to the second power. So you're going to take both sides of your equation to the second power. Okay? You're going to square both sides. That will get rid of your radical sign. And then it's just solve the equation. From there, you should know exactly what to do. So solve the rest of it. And then you always check for extraneous solutions. Extraneous solutions just are solutions that don't work in the original equation. So when you find a solution that doesn't work, ooh, do you like my new color? I like it too. Solutions that don't work in the original equation. And you won't see a lot of extraneous solutions, but the fact that they can show up means you should be checking your answer each time just to make sure that there aren't extraneous solutions. So take a look at this situation. Number 1, is the radical isolated? Yep, the only thing on the left side of our equation right now is under that radical symbol. So if everything is under the radical on one side of the equation, it is isolated. So step 1 is done. Step 2, square both sides. So you are going to square this and square that. What happens when you square the square root of x? It's x. When you square and square root something, whatever's under the radical is the thing you're left with. So this is going to be x equals what? 81. Okay, that's your answer because we know what x is. Then what you should be doing at that point is check your answer. So if the square root of x, so the square root of 81 equals 9, then it checks out. Is that a true statement? Yes, so 81 is a solution to this setup. Okay, look at number 2. Is your radical isolated? Is everything under the radical? Mm-hmm. So if something's outside of the radical here or behind it, not under the bar, then it's not. But if everything is under the radical's isolated. So once your radical is isolated, what do? Square both sides. So square this and square this. When you square and square root something, it cancels those out. So we're left with what? M plus 5. It just gets rid of the radical. Okay. So m plus 5 equals 4. And then you solve. Take away 5, so m is -1. Then you plug that in to just make sure that it's not extraneous. So the square root of -1 plus 5 should equal 2. Well, that's the square root of 4. Does the square root of 4 equal 2? It sure does. So that's a good answer. -1 plus 5. So I took the answer and I replaced it in the original equation. Oh, 2 squared. You square both sides of the equation. I squared, so if this whole thing is square rooted and then we square it, a square and a square root are inverse operations, so they just essentially cancel each other out. So then what you're left with is whatever's under the radical. So like if I had the square root of x plus 3 and I square that, that takes this and this away. The 2 wasn't under, is that what you said? We're taking this whole thing to the second power. So square rooting something is undoing a square, right? They're opposite of each other. So if you square it and square root it, then they go away. Okay? Okay, you do number 3. See if you can solve that. Are you good? So you are squaring that whole. So you don't square the 5. You square the root. Okay, what'd you get? 9. Did you get 9? Hopefully. It is isolated. Everything is under that radical. So you're going to square both sides. That's going to get rid of the radical and the square. Over here, it's 36. And then you're going to divide by 4. So y is 9. Good? If you plug that back in, 6 would have to equal the square root of 4 times 9. So the square root of 36 is 6. That checks out. How is 4 different here? There's division, which is going to lead to multiplication in the end. Okay, but is this isolated? This is isolated. So you can square everything right away. That gets rid of all of that. So it's a divided by 3 equals 49. How do you solve that for a? Multiply by the reciprocal or multiply by the denominator really is what you're doing here. So a is 49 times 3, which is 147. And then again, you would plug 147 in here to check it. 147 divided by 3 is 49. The square root of 49 is 7. So it checks out. Good on that? Okay. These last 3, we're going to jump to number 9, are a little bit different. I want to show you on this one how this plays out. I have a shortcut for you, but you could also do it the same way we've been doing it. So I'll show you the way we've been doing it, and then I'll show you how you don't actually have to go that far. Okay? Is your radical isolated? Everything's under the radical? No. So it's not isolated. So the first step is make sure it's isolated. How do we do that? What's my first move? We can't square yet because we got to get it by itself first. Subtract 1. We're going to take a 1 away here and a 1 away here. So now you have a negative square root of x plus 2 equals 3. Okay? Is it isolated? There's still a negative 1, okay? And a lot of people don't see it as a negative 1, which you don't have to see it as a negative 1 necessarily, but there is a number there. So to get rid of that negative 1, if you divide by negative 1 on both sides, then you get the square root of x plus 2 equals negative 3. Is it isolated? Now it's isolated. Okay, so now here's the deal. I'm going to show you how at this point you actually don't have to go any farther in just a minute, but I'm going to show you with the method we've been doing why that will be. What would you do next? You'd square both sides. So if I square this, I have to square this, and I get x plus 2 equals 9. Take the 2 away, and x is 7. Okay? Now plug this back in. 7 plus 2 is 9. The square root of 9 equals negative 3. That is a negative. That is not the principal root. And we are looking for the principal root on these. What I was saying earlier is when you get to this point, the square root of something equals a negative. Okay? Something times itself can never equal a negative. So if you get to this point in a problem ever, you can just say no solution, because you didn't get the principal root here as it was. It doesn't equal a negative when you square root something, okay? So I don't care if you do that right at this point, or if you want to keep solving and check your work, that's fine too. But you don't have to do all that for me. As soon as you see a radical equals a negative, you may just say no solution, okay? That would be considered an extraneous solution. Okay, look at number 11. How would you solve that? Is it isolated? No. So what do we have to do first? Not minus 2, because this is 2 times the square root. No. You add 11. Yeah, you're going to add 11 to both sides. So 2 times the square root of k minus 4 equals 8. Is it isolated? No. Divide by 2. So divide by 2 here, divide by 2 here, and you get the square root of k minus 4 equals 4. Okay, is it isolated? Yes. Okay, what do we do once it's isolated? Not square root, square. Square both sides. So it's going to be k minus 4 on the left and 16 on the right, and now just solve for k. So add 4, and k is 20. Yeah, Sydney.
Do we have to check for extraneous solution?
I mean, they show up every now and then, so it's a good idea to check for extraneous. If you don't show me the work, here's how I think of it. If you just plug it in your head, or you plug it into a calculator, I don't need to show me all the work on the check it. But if you don't check it and it's extraneous, then you're giving me an answer that's not actually an answer. So what I typically do is I just go, okay, if I put a 20 there, that's 16. The square root of 16 is 4. 4 times 2 is 8. 8 minus 11 is negative 3. So I just kind of do it in my head. But if you want to write it out, write it out. If you want to just do it in your head, that's fine. Just make sure you're doing it correctly. Then you would just say no solution. Yeah.
Can you try 12?
Sure. 13 is the next one I was going to do. So we'll do 12 and 13, and then we'll be done. What do you do on 12? You subtract the 7 first. So this is 4 equals the square root of 8h over 3. Is this isolated? No. Because the radical, notice where the radical is. If the radical was like this, then it's isolated. But the radical's just in the numerator on this one, so it's not. So how do we isolate it? Multiply by 3. So this is 12 equals the square root of 8h. Now is it isolated? Now it is. What do you do? Square both sides. So you get 144 equals, this will be 8h, because those cancel each other out. And then you would just divide by 8. What's 144 divided by 8? 18? You got it? Yeah.
I multiplied the 3 first.
Yeah, you got to do reverse PEMDAS. So you have to add and subtract first.
No, but on the very first step, I multiplied each side by 3.
Right, that's what I'm saying. You have to do PEMDAS in reverse when you solve equations. So the last thing.
I got the same answer.
You got the same answer?
Yeah.
You got lucky then. That's a fluke. You want to add and subtract first, then multiply and divide, then exponent, then parentheses when you're solving an equation. Yep, last one. Okay, this has radicals on both sides. Is there anything outside of the radicals? No. So when you're here, then all you do is you square both sides, and essentially it just gets rid of all your radical, and you solve. So you would square and square. That would be r equals 42 minus 2r, and then solve for r. So add 2r, and you get 3r equals 42. What's your last step? Divide by 3. So r is 14. And again, if you plug that in, the square root of 14 would have to equal the square root of 42 minus 2 times 14, so 28, which is 14. So the square root of 14 equals the square root of 14, so that checks out, so that's a good answer. Okay? You guys, you did it. Algebra 1 in the books. Nothing new.